Hello and welcome to Quick and Nerdy, an MSP-friendly channel dedicated to Veeam-powered solutions for BAS and DRAS offerings. As always, I'm your host, Brandon McCoy, Systems Engineer Advisor for our Veeam Cloud and Service Providers. And today, we're going to be talking about the Veeam components, specifically for backup and replication and Cloud Connect. So there's a lot of different Veeam products, and within each one of those products, there's also quite a few different components that kind of make up the whole Veeam process, whether that is the data movers or the repositories. And so I figured I'd take just a little bit of time to talk about what each component does and a little bit on sizing. Now, some of the sizing is dependent upon X, maybe the size of your environment or what you're trying to do. So I put in sizing where I can. I'll give some disclaimers and some caveats here and there. And I'm also going to put some links in the description of the video that includes our best practice guide, our Veeam calculators, and some help centers specifically to some of these components that may vary. So let's get right into it. Let's start with an agenda. So like I mentioned, we're going to be talking about backup and replication. So we're going to start there first. Of course, that is our core flagship product. We're then going to move on to Cloud Connect and Service Provider Console. I like to talk about both of those together because they kind of tie in to each other very well. And we'll wrap it up. So let's jump in. So we're going to start with backup and replication, or as we like to call it around here, VBR for short. So starting from the left-hand side of the screen, of course, you have your production environment. So Veeam backup and replication, if you don't know, backs up virtual machines. Today we support VMware, Hyper-V, Nutanix Acropolis. We just released support for Proxmox. We also do some Oracle hypervisors as well. Not as familiar with those. We're primarily going to be talking about VMware and Hyper-V, a splash of Acropolis maybe. Some of the Proxmox stuff, that's still very early, so I really encourage you to read some of the documentation. And also keep in mind that these things can change. So, it is August 2024. So always keep that in mind when you're looking at these videos and these docs to make sure that nothing has changed. So backup and replication is comprised of three primary components, and those are the components that you see on the top. So the backup server, the backup proxy, and the backup repository. So the backup server is Veeam backup and replication. That's the GUI. That is where you're creating jobs, you're scheduling things. You're also using this to add the other components of Veeam to different Windows or Linux instances. So as it is today, Veeam backup and replication is installed on a Windows machine. Our PM team has promised that by 2025, Veeam will also run on Linux. Now today, some of these other components like the proxy, the repository, those run on both Windows and Linux. But today, right now, backup and replication requires a Windows machine. And that Windows machine needs around 4 cores and 8 gigs of RAM to get started. Now that's not the minimum. I believe the minimum is 2 cores, but I really recommend that you just start with 4 cores and 8 gigs of RAM. If someone asks me to size a VBR server without having any information on the environment as far as size and scope, that is usually where we start. Now, you'll also want to keep in mind some things like how many concurrent jobs the VBR server can run at the same time. So depending on the type of job that you set, there is single file backup job, which is the old way of doing things. And then there's the per VM backup job, which that's what we typically recommend. And if you're doing a per VM backup job, the max VMs you can put in there is 300. We'd recommend somewhere around 50 to 200 is a good kind of balancing act there. So when it comes to the number of concurrently running jobs that your Veeam server can handle, again, we're starting with the 4 core, 8 gigs of RAM, and then for each additional 10 concurrently running jobs, you need 1 core and 4 gigs of RAM. Now the next component is the backup proxy. This is the data mover. This is what takes backups from the production hypervisor to the repository. and keeps us agentless. So this is only going to be for virtual backups, and the proxy is the Veeam backup server by default, but if you want to specify a dedicated backup proxy, and in larger environments you will most likely need to do this, you want to go for around 1 core and 2 gigs of RAM per task. Now for a proxy, a task is considered a VMDK or a VHDX, so a virtual disk, right? Keep in mind that just because you have, X number of virtual disks does not mean that you need that many cores and gigs of RAM on your proxy. It just means that if, let's say, you're backing up 8 virtual disks and you only have 4 cores on your proxy, we'll only be able to back up 4 of those disks in parallel, and the other 4 will be in a queue waiting for one of the cores of that proxy to be available. You also have to keep in mind things like proxy affinity. So by default, Veeam is just going to use whichever proxy is available. However, if you're setting affinity rules, then certain proxies are locked down to certain jobs. The next component is going to be the backup repository. So the backup repository by default is the largest drive letter on your Veeam server. This is great for all-in-one deployments. However, if you're going to have a dedicated repository, you'll want to size that separately. Now for the repository, as you can see, it's 1 core and 4 gigs of RAM per task. Now, one thing I want to speak about on this is really the old school method of the repository, the 1 core, 4 gigs of RAM per task, and also a task is typically considered a job on the repository. However, if you're doing a per VM backup job, then you can look at the number of virtual disks that the proxy did, and you kind of have that same type of disk to task ratio. In addition, the best practice sizing guide has recently been updated to suggest that when you're looking at repository sizing, you should take the number of proxy cores that you have used and divide that by 3. The reason for this is because the proxy is doing a lot of compression and deduplication, so by the time that it hits the repository, that disk and that task is much smaller and can be streamlined. So, as an example, if you have 12 cores for a proxy, then you should have 4 cores for a repository. Okay, so somewhere in the middle of these two methods, the old school method of 1 core, 4 gigs of RAM per task, and the how many proxy cores do you have, divide that by 3. But it is still the 4 gigs of RAM per core that you have. One last thing to consider is that on both the backup proxy and the backup repository, you need to also be aware of your max concurrent tasks. So in the Veeam server, if you look at your proxy, if you look at your repository, there's a place where you can set the max number of concurrent tasks. For the repository, you should probably look at 3 concurrent tasks per core and go from there. With the proxy, typically it's 1 core per task, but you can always kind of set that and go up just to kind of push it to its limit and try to get the most use out of the proxy and repository. And I really recommend that you look at the best practice guide to get a more thorough understanding of the max concurrent tasks with the data mover, which is the proxy, and the repository. These are going to be 2 of the main components in terms of how fast can I expect my backups to go. Okay, now those are the 3 components like I mentioned. The ones underneath this are optional components, but they are in a lot of cases in use. So the first one is the mount server. Okay, so the mount server is used for things like instant VM recovery, sure backup, right, where we're taking a backup and we're mounting it so that we can do different types of restore operations without actually having to spin up that whole machine. Now by default, like most other components, that is the Veeam server, and in a lot of these smaller environments, people just install Veeam. All the other components and services are installed on that one computer, and they seem to be okay. But if you start getting slowness, your performance isn't what you think it should be, that's when you need to look at maybe splitting up some of these roles. The next component is going to be the gateway server. Now, when we install Veeam and we add repositories to different machines, we install something we like to call data mover services on these components. So basically, Veeam is just installing some different services on your Windows or Linux computers so that Veeam can talk to it and knows how to work with it. We can only install those data mover services on OSs like Windows and Linux. So if you are backing up to something like an SMB, an FS share, Synology NAS, or some other kind of file share, we cannot put data mover services on NAS devices. In that scenario, we are actually leveraging something called a gateway server. So the gateway server is a Windows-only machine that is going to be responsible for ingesting data from the proxy and then writing that to the share folder. So if you don't have a Windows or Linux backup repository, then you need to instead size for the gateway server, which is more or less the same type of requirements as the backup repository that you see above. If you're backing up to a tape device, keep in mind we can't back up to a tape first, so you'll need to back up to a local disk. Then you can do a copy job to a tape server, and that tape server needs around 2 gigs of memory per task. You can look in the Help Center for exactly how many CPU. Most of these optional components don't list that. They just require a certain amount of memory, and obviously they'll need enough CPU to run and operate, but there really isn't a size for the number of CPUs on these components. And finally, the WAN accelerator. So you're looking at about 8 gigs of RAM. There's also some other considerations for WAN accelerators, like are you using SSDs? What kind of bandwidth do they have? The WAN accelerator is something on the target and the source and target side, which is a folder of blocks that are repetitively sent to the repository across the internet. Typically, these are OS blocks. And that way, when you're doing new jobs, those existing blocks can be reused and repurposed in a caching mechanism. All right, so real quick, let's talk about some honorable mentions, right? So we've got a few other components that I really didn't have time or really wanted to get into. The Proxmox worker, so this is just, the Proxmox data mover, similar to the proxy. You've got cache repositories and general purpose proxies. Both of these are used for unstructured data, things like file share backups, NAS backups. And you've also got CDP proxies. So CDP is our continuous data protection. This is specifically for VMware to VMware for customers who need things like 2-second RPOs, which is, just like a whole other conversation. And you've also got the database itself. We did move from SQL Express to PostgreSQL for our database on backup and replication. So typically the built-in PostgreSQL is going to be enough for you. If you do need to have a dedicated database server, you'll also want to look into the Help Center and take those into consideration. All right. Now let's move into the Veeam Service Provider Console and the Cloud Connect, or VSPC and CC as we like to say around here. So I put these two together and we're going to go through them. So first and foremost, Cloud Connect, that is what allows service providers to offer their own infrastructure to their customers for BAS and DRAS without needing any VPNs or complex networking. It is also used to connect customers to the Service Provider Console, which is a single pane of glass for service providers to get some centralized management and visibility. Now, all of that data is going to come through port 6180 over a TLS or Transport Layer Security, basically an upgraded version of SSL. And the first thing the customer is going to hit is something known as the Cloud Connect Gateway. So I had to reuse the Gateway Server icon, so not to be confused, the Gateway Server is to write backups to a file share. The Cloud Connect Gateway is so that customers can come into your environment or at least be visible without any kind of VPNs. So this is where that TLS service is coming from. This is a service installed on a Windows machine. This is not something that is installed by default on the Veeam server. Now, 4 cores and 8 gigs of RAM for a max of up to 500 tenants is what the documentation says. In my experience, I have a lot of service providers who do all-in-one Cloud Connect and Cloud Gateway. I personally think 4 cores is a little extreme. I think, something more like 2 cores, 2 gigs of RAM can handle quite a bit, but it really does depend on the size and scope of how many tenants you have. But again, it's in my experience that the gateway server doesn't have a whole lot of horsepower needs. You can also have multiple cloud gateways, and we're going to target these through round robin if you have DNS and A records configured properly. Now, the Cloud Gateway is created on a Windows machine, and you do that through your Cloud Connect server, and your Cloud Connect server is backup and replication. So you see here we got backup and replication on the screen, and you're going to install a Cloud Connect license, and that is going to change the functionality of your Veeam server. Now it's not a backup and replication server. You're not doing backups from it. You're only using this to set up your BAS and DRAS infrastructure. Now the Cloud Connect server is once again the management interface, but the receiving end rather than the VBR that's doing the backups. This typically is a 4-core, 8 gig of RAM server. You may need to up the resources on this depending on how many tenants you have. But honestly, the Cloud Connect isn't really doing much. It's not running jobs. So I think the 4-core, 8 gig of RAM is fine for that. This also comes with PostgreSQL by default. Now you've got your Cloud Connect repository. Same concept here as the on-prem backup and replication repository, right? So I won't go over the sizing again there. Just know that with this, you have X number of tenants or customers that are sending you backup. So you need to set your max concurrent tasks at a global level on the repository in the Cloud Connect interface. But then you also need to consider throttling or limiting how many jobs a tenant can send you as well. So those are the only differences. We're taking this repository and splitting it up into multiple Cloud Connect repositories, one for each tenant. Okay. I've also got the hypervisors here, just VMware and Hyper-V. This is going to be for Cloud Connect replication and or Cloud Connect CDP, where we create something called a hardware plan, which is just an abstraction of data store space, CPU memory, and X number of VLANs up to 9, so that your customers can not only send backups, but actually replicate their entire infrastructure to you, and in a disaster, they could push a button, and the whole environment would be up and running. There's some other components with that, something called the Network Extension Appliance, but I'm not going to really get into that. I think it's a little outside the scope of your basic components. Lastly, we've got the Service Provider Console. So the Service Provider Console gets installed on a Windows machine, and there's a Web UI component to this, which can be installed on a separate Windows machine, or it can be the same machine. The Web UI is, of course, so you, your techs, or your customers or resellers can log into the Service Provider Console with their specific credentials and see their specific stuff. And the Service Provider Console is your single pane of glass, one-stop shop for licensing, managing Veeam agents and pushing them out, installing backup and replication, alarms, licensing, the list goes on. For the Service Provider Console, I didn't put any sizing here because it really depends on the number of tenants you have. And so I'm going to post some links in there so that you can see what is required depending on the number of tenants. Now, most of this can all be an all-in-one as well. So the Cloud Connect server, the Cloud Connect repository, the Cloud Connect gateway, the Service Provider Console, and the Web UI. I would be cautious about doing something like that, depending on the number of tenants you have, the single point of failure, and just overall scalability. You can always start with an all-in-one and build out as you need. And in my experience, I found that when you do some of these all-in-one deployments, you don't necessarily have to add up all the cores and gigs. You can a lot of times get away with a lot less, but I would kind of stick to some of the requirements, and you can be a little more liberal with your sizing of all-in-one deployments. Okay, you also want to think about security for things like the gateway server, the web UI, because those are assumedly pointed to the internet even behind something like a firewall. All right, so that's it for this video. There are other products, there are other components, but really these are the core components and a few miscellaneous ones that we see out there. So hopefully this gives you a good idea of what these different things are, so that when you're installing these, you're not necessarily doing a next finish. You're looking at the different components and sizing those accordingly. So that's it for this video. I hope you enjoyed it, and we'll see you next time. Until then, keep on Veeaming in the free world.